You look up, sky is dark, moon is there, but sometimes 3 or 4 times a year, that moon swings closer to Earth than usual, 14% larger in diameter, 30% brighter. We call it a supermoon. Except nobody in astronomy used that word until 1979 when Richard Nolle, an astrologer working out of Dell Horoscope magazine, coined it after reading a paper on perigee spring tides by a NOAA hydrologist named Fergus Wood. Nolle defined it as a new or full moon occurring within 90% of the moon's closest approach to Earth. Not scientific, no precise definition, but the name stuck. Now everyone from NASA to casual observers uses it. The technical term is perigee syzygy of the Earth-Moon-Sun system. Perigee means closest point in orbit. Syzygy means alignment. When Earth, Moon to where, and Sun line up at the moment the moon reaches its nearest point to our planet, you get what people now call a supermoon. 7 types stand out, some massive, some rare. Some combining phenomena that haven't aligned in over a century. This is what happens when geometry, gravity, and timing converge in ways most people will witness once, maybe twice, in their entire lives. If you value documented astronomical history and celestial mechanics like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from Fred Espenak's Astropixels lunar perigee tables published through October 2025. NASA's Lunar Reconnaissance Orbiter documentation updated June 2023, and EarthSky's Supermoon analysis from April 2018, verifying historical perigee data back to 1948. Now back to the information. Number 1, the extreme proximity supermoon. November 14th, 2016, the moon reached perigee at 11:23 Universal Time, distance to Earth's center, 356,509 kilometers, 221,524 miles. 2.5 hours later, full moon phase peaked at 13:52 Universal Time. That alignment, perigee and full moon within hours of each other, hadn't happened that close since January 26th, 1948, 68 years. For context, 1948 was when the 200-inch Hale telescope on Mount Palomar was dedicated, when the Cleveland Indians last won the World Series before their 2016 drought ended, when most of the world had never seen television. The November 2016 supermoon appeared roughly 14% larger in diameter than a full moon at apogee, the moon's farthest point from Earth, 30% brighter due to the inverse square law of light. The difference in distance between perigee and apogee that month measured 50,153 kilometers, 31,164 miles. That's the distance from New York to Tokyo. The moon's orbit is elliptical, not a circle, one side always closer. The variation happens because of gravitational forces, sun pulling, earth pulling, planets exerting minor tugs. Noah Petro, deputy project scientist for NASA's Lunar Reconnaissance Orbiter mission, explained in 2016 that these different gravitational forces pulling and pushing on the moon give us opportunities for these close passes. The November 2016 event became known globally. Photographers from Bari, Aceh, Italy captured the International Space Station transiting across the moon's face. Images from Northamptonshire, England, showed crater definitions preserved across the whole lunar surface using polarizer filters from Hayling Island, Hampshire. Observers noted the moon looked slightly bigger than normal but needed foreground objects to give it scale. The moon illusion enhanced the effect. When the full moon appears close to the horizon just after moonrise, or before moonset, it looks exceptionally large. Not because it actually is larger, but because your brain compares it to trees, buildings, mountains in the foreground. The angular size remains constant at roughly 33.5 arc-minutes at perigee, about 30.5 arc-minutes at apogee. Your eye can't detect that 4% difference without side-by-side comparison, but photographs prove it. The brightness difference is real. More reflected light reaches Earth when the moon is closer. That brightness you can see. Tides rose higher in the days following. Perigean spring tides. When full moon coincides with perigee, the combined gravitational pull of moon and sun creates tidal ranges about 5 centimeters larger than regular spring tides. King tides, some call them. Research based on 25 years of daily observations on sandy beaches published in peer-reviewed journals showed that larger tidal ranges from supermoons increase beach erosion in the upper swash zone. Morphology fluctuates in cycles related to the supermoon. Erosion during high waves becomes more severe when coincident with extreme perigee. The next time the moon will come that close, November 25th, 2034, distance 356,448 kilometers. just 61 kilometers closer than 2016, 18 years apart. That's not random. 14 lunar months almost exactly. Equal 15 returns to perigee. 14 times 29.53059 days equals 413.428 days. 15 anomalistic months, perigee to perigee, each lasting 27.55455 days equals 413.318 days. 1 year, 1 month, 18 days. The cycle repeats. After 2034, the pattern continues. December 6th, 2052. 356,429 kilometers. Closest full supermoon of the entire 21st century. December 17th, 2070. December 28th, 2088. Each one closer than 356,500 kilometers. For the moon to approach closer than 356,400 kilometers is rare. It won't happen at all in the 21st century from 2001 to 2100. Won't happen in the 22nd century from 2101 to 2200. Last time was January 14th, 1930. 356,397 kilometers. Next time won't be until January 1st, 2257. 356,371 kilometers. 327 years between occurrences. Number 2. The super blue blood moon, triple convergence, witnessed, documented, January 31st, 2018. The moon was at perigee January 30th at 0455 Universal Time, 356,603 kilometers away. Less than 36 hours later, full moon occurred at 0827 Universal Time, January 31st. Second full moon of the month, blue moon by modern definition. The term comes from the lunar cycle, lasting 29.53 days, while most calendar months run 30 or 31 days. Every 2.7 years, 1 month gets squeezed 2 full moons. The second one earns the blue moon label, not because it looks blue. In 1883, Krakatoa volcano exploded. Dust and ash filtered wavelengths of sunlight. Some observers reported a moon with a blue tinge, but typically, blue moons look like any other full moon. The January 2018 event had a third component, total lunar eclipse. As the moon passed through Earth's umbral shadow, sunlight bent through Earth's atmosphere, blue light scattered, red light remained, the moon turned copper red, then dark red, then nearly black during totality. Blood moon, not a scientific term, just descriptive. The reddish glow comes from every sunrise and sunset on Earth, simultaneously illuminating the moon's surface. The convergence of all three phenomena, supermoon at perigee, blue moon as second full moon of January, and total lunar eclipse causing blood red coloration, created what media outlets called the super blue blood moon, first visible from the United States since March 31st, 1866. 152 years, the canon of lunar eclipses confirmed the previous occurrence. In 1866, Abraham Lincoln had been dead for 1 year. The Civil War had ended. Reconstruction was underway. No electric lights, no telephones, no photographs of that moon survive in detail. The 2018 event, by contrast, was photographed from every continent. Central and Eastern Asia, including most of Siberia, the Philippines, Indonesia, New Zealand, and most of Australia, saw the eclipse in evening skies. For Western Asia, the Indian subcontinent, the Middle East, and Eastern Europe, the eclipse was underway as the moon rose along the U.S. West Coast, totality began at 0451 Pacific Standard Time. The eastern United States caught only the initial stages before moonset. The instant of greatest eclipse occurred at 0331 Universal Time. Totality lasted 1 hour, 16 minutes. During that window, the moon's apparent diameter measured 356,604 kilometers from Earth's center, 14% larger than an average full moon. The brightness during totality dropped dramatically because Earth's shadow blocked direct sunlight. But the refracted red light gave it an eerie glow visible to the naked eye even in urban areas with light pollution. The next super blue blood moon visible from North America, January 31st, 2037, 1 metonic cycle later, 19 years. The metonic cycle describes the period after which lunar phases recur on the same calendar dates. Discovered by ancient Greek astronomer Meton of Athens in 432 BCE. 19 solar years, almost exactly equal 235 lunar months. The cycle allows prediction of eclipse patterns. The 2037 event will match the 2018 geometry closely. Moon at perigee, second full moon of January, total lunar eclipse, all three converging within hours. Photographers who were 20 years old in 2018 will be 39 in 2037. Those who were 50 will be 69. One generation's span. Number 3, the harvest supermoon. Timing defines this one, not distance alone. The harvest moon is the full moon occurring closest to the autumnal equinox. Usually falls in September, sometimes in October. Approximately once every 3 years, October claims it. The equinox marks the moment when Earth's equator passes directly through the center of the sun. Day and night, equal length. Roughly September 22nd or 23rd, depending on the year. When that full moon also occurs near perigee, you get a harvest supermoon. September 17th, 2024. Moon reached full phase while within 90% of its closest approach. Distance, 357,344 kilometers. The harvest moon earned its name in pre-electric times. Farmers depended on moonlight to harvest crops after sunset. The autumn equinox creates a unique optical effect. The moon's orbital plane relative to the horizon causes the full moon to rise faster than usual for several consecutive nights. It appears to rise at nearly the same time, close to sunset, night after night. Provides extended bright moonlight during the critical harvest season. The angle matters. At mid-northern latitudes, the moon's path makes a shallow angle with the evening horizon around the autumn equinox. This means the moon rises only about 20 to 30 minutes later each successive night, instead of the typical 50 minutes. For 3 or 4 nights, farmers had reliable illumination flooding their fields from dusk through midnight, essential when winter approaches and crops must come in. October 17th, 2024, Al-Ajid delivered both. Harvest moon by proximity to equinox, supermoon by proximity to perigee. Distance, 357,364 kilometers, 222,056 miles. The closest full moon of 2024, skywatchers from Oregon photographed it shining through thin fog, lower rim deep crimson near the horizon. From Gaza City, photographers captured it rising over buildings. From Rome, observers watched it set below the skyline. The international dateline complicates naming. In some time zones, it was technically October 18th, but the astronomical moment of full moon, when sun and moon reach 180 degrees apart with Earth between them, occurred at specific universal time coordinates. The brightness allowed detailed crater observation with amateur telescopes, Mare Imbrium, the Sea of Rains, Mare Serenitatis, the Sea of Serenity, Mare Tranquillitatis, where Apollo 11 landed in July 1969, all visible in sharp relief. The supermoon phase increases surface detail visibility because more light reflects from the lunar regolith. The angle of illumination, directly opposite the sun, creates full lighting across the visible hemisphere. No shadows in the craters. Makes some features harder to see compared to quarter moon phases when shadows define topography. But brightness and size combined create visual impact. November 5th, 2025, will bring another harvest supermoon for some definitions. Distance, 356,980 kilometers, 221,817 miles. Closest full moon of 2025. The beaver moon by traditional Native American naming, but also near enough to equinox timing that some sources classify it as a late harvest moon. The classification depends on which lunar month contains the equinox moment. Definitions vary. The Old Farmer's Almanac uses one method, Royal Observatory. Greenwich uses another, both valid. The astronomical fact remains. Full moon at or near perigee, occurring close to equinox, providing maximal illumination for harvest. The physics doesn't change regardless of the name. Number 4, the micromoon counterpoint, opposite phenomenon, equally real. When full moon occurs at or near apogee, the moon's farthest point from Earth, astronomers call it a micromoon. Distance reaches 406,000 to 407,000 kilometers, 252,000 miles. 12 to 14% smaller in apparent diameter than a supermoon, 7% smaller than an average full moon. The contrast illustrates orbital mechanics. March 14th, April 13th, and May 12th, 2025, all qualified as full micromoons. April 13th distance, approximately 406,712 kilometers. The farthest point in 2025, November 20th, 2025, the moon will reach its most distant apogee for the next 18 years. That's a micro new mooning, invisible because new moon phase places it between Earth and Sun, but the distance record stands. Photographers document the difference. Side by side, comparisons show the size variation clearly when captured with identical equipment and settings. Celestron Power Seeker 60 AZ images from India in 20 to 24 compared the August 19th supermoon to the April 12th micromoon. Diameter difference visible even in amateur telescope shots. The brightness difference is more noticeable than size. 30% dimmer at apogee versus perigee, that you can see with naked eye if you remember what a supermoon looked like and compare it mentally to a micromoon 6 months later. But most people don't notice. Memory fades. The moon looks like the moon. Only photographs preserve the evidence. The moon illusion affects both equally. Low on the horizon, near buildings or mountains, both supermoons and micromoons look enormous. High overhead and empty sky, both look small. Your brain processes apparent size based on context clues. No context, smaller perceived size. The angular measurement stays constant for each type. Supermoon, 33.5 arc minutes. Average moon, 31 arc minutes. Micromoon, 29.4 arc minutes. Human eye resolution limit is about 1 arc minute under ideal conditions. That's 60 arc seconds. The supermoon to micromoon difference spans 4.1 arc minutes. Theoretically detectable, practically difficult without reference frame. What matters most is reflected light, illuminance, the amount of light energy reaching Earth from the moon's surface. Inverse square law governs this. Double the distance, 1/4 the light. The supermoon sits roughly 357,000 kilometers away. The micromoon sits roughly 407,000 kilometers away. Ratio, 1.14. Squared, 1.30. 30% brighter. That's measurable with light meters, observable with human eyes adapted to darkness. If you see both in the same lunar year, the brightness difference becomes apparent, especially if clouds or haze partially obscure them. The supermoon punches through. The micromoon dims noticeably. Number 5, the proxygeny phenomenon. Closest of the close, narrowest windows. Fergus Wood, no-way hydrologist, coined the term proxygeny in 1976 in his paper Strategic Role of Perigene, Spring Tides in Nautical History and Coastal Flooding. Proxygeny describes the event when perigee and full or new moon occur within 10 hours or less of each other. Tighter alignment than typical supermoon, greater tidal effects, more precise timing. The November 14th, 2016 supermoon qualified. Perigee at 11:23 universal time. Full moon at 13:52 universal time, 2 hours 29 minutes apart. Proxygeny, the September 28th, 2015 total lunar eclipse qualified. Perigee and full moon approximately 1 hour apart. Distance, 356,877 kilometers. The total eclipse provided bonus visual drama, blood moon coloration at proxygeny distance. Richard Knoll added the concept of extreme supermoon in 2000. Any new or full moon at 100% or greater of mean perigee, tighter than his original 90% threshold. Fewer events qualify. November 2016 made the cut. So did January 1948. So will November 2034 and December 2052. The Saros cycle predicts these 123 synodic months. Full moon to full moon equal 239 returns to perigee, also equal 242 returns to the same node where the moon's orbital plane intersects Earth's orbital plane. 1 Saros cycle, 6,585.3216 days, 18 years, 11 days, 8 hours. Eclipses repeat with nearly identical geometry. 1 Saros cycle apart. So do proxygeny supermoons if they coincide with eclipses. The 2015 September proxygeny total lunar eclipse repeats October 8th, 2033. 1 Saros cycle later, moon will turn full at 10:58 universal time. Swing to proxygeny 1¼ hours later at 12:11 universal time. Total eclipse visible from Western North America, Eastern Asia, Australia. The cycle continues. October 19th, 2051, October 30th, 2069. Every 18 years, 11 days, the pattern recurs. Allows prediction centuries in advance with accuracy down to minutes. Ancient Babylonian astronomers discovered this around 6th century BCE, used it to predict eclipses for religious ceremonies and agricultural planning. We use it to forecast optimal photography opportunities and plan scientific observations, same mathematics, different tools. Number 6, the name moon supermoons, cultural overlay on astronomical fact. Every full moon carries traditional names. January, wolf moon, Mars, named after howling wolves in midwinter. February, snow moon for heavy snowfall. March, worm moon, earthworms emerging from thawing soil. April, pink moon, after pink phlox wildflowers. May, flower moon, peak spring blooms. June, strawberry moon, strawberry harvest season. July, buck moon, when male deer grow new antlers. August, sturgeon moon, sturgeon fish abundance in Great Lakes. September, harvest moon as discussed. October, hunter's moon, optimal hunting light. November, beaver moon, beaver dam building season or trapping season. December, cold moon, onset of deep winter. These names come from Native American tribes, colonial American settlers, and European traditions passed through generations. The Old Farmer's Almanac published comprehensive lists starting in 1792. Not scientific, but culturally significant, helps people track seasons without calendars. When a supermoon coincides with one of these name moons, the media compounds the names. Super Strawberry Moon, Super Buck Moon, Super Beaver Moon. Technically accurate if the full moon occurs at perigee during the corresponding month. Creates public interest, gets people looking up. November 5th, 2025, Super Beaver Moon, closest full moon of the year, December 4th, 2025. Super cold moon. Nearly as close, October 16th, 2024, Super Hunter's Moon. Native American tribes use these moons as calendars. Each name marked seasonal events critical for survival. The wolf moon in January told them wolves would be most desperate for food, most dangerous, most likely to approach camps. The worm moon in March indicated planting season approached, soil warm enough for seeds. The sturgeon moon in August meant fish runs peaked. Time to preserve food for winter. The supermoon enhancement doesn't change the cultural meaning, but it adds visual drama. Brighter moon, better light for those historical activities. Hunter's tracking game could see clearer under a super hunter's moon than under a regular full moon. Not by much, 7% brighter, but every bit of light mattered before electric torches. Beavers building dams worked by moonlight. Brighter moon, longer working window. The cultural names persist because they connect us to seasonal cycles. The supermoon designation adds astronomical accuracy, tells us the moon is also at perigee, both layers of meaning valid. Both worth remembering. Number 7, the eclipse supermoons. When shadow meets proximity, total lunar eclipses occur when Earth passes directly between sun and moon. Earth's shadow, the umbra, covers the moon completely. Sunlight bends through Earth's atmosphere, refracts into the shadow, illuminates the moon with red-shifted light, blood moon coloration. If this happens when the moon is also at or near perigee, you get an eclipse supermoon, relatively rare. In the 21st century, 2001 to 2100, there will be 87 total lunar eclipses. Of those, 28 occur during supermoons, 6 occur during micromoons. The rest fall somewhere between. September 28th, 2015, supermoon total lunar eclipse. Distance, 356,877 kilometers. Totality visible from Western North America, Eastern Pacific, Western South America, Europe, Africa, Western Asia. Duration of totality, 1 hour 12 minutes, January 31st, 2018 as detailed earlier, super blue blood moon with total eclipse. Next supermoon, total lunar eclipse, May 26th, 2022. But that one wasn't extremely close. Distance, 360,306 kilometers. Qualified as supermoon by 90% threshold, but not among the year's closest perigees. The next truly close supermoon total lunar eclipse, October 8th, 2033, predicted by Saros cycle as discussed, 1 cycle after the 2015 event. Will be visible from North America, South America, Western Europe, Western Africa. The mechanics matter. During totality, the moon moves through the darkest part of Earth's shadow, completely loses direct sunlight. Only refracted light reaches it. That refracted light passes through hundreds of kilometers of Earth's atmosphere along the edges of Earth, as seen from the moon's perspective. Every sunset and sunrise happening simultaneously around Earth's limb. Blue wavelengths scatter, Rayleigh scattering. Same process that makes Earth's sky blue and sunsets red. Red wavelengths penetrate, illuminate the moon. The exact color during totality varies. Depends on atmospheric conditions on Earth at that moment. If major volcanic eruptions injected ash into the stratosphere recently, the moon appears darker, more brown or gray. If the atmosphere is clear, the moon glows bright copper red or orange. Observers can estimate atmospheric quality by observing lunar eclipse colors. The Danjon scale rates eclipse brightness from 0. Very dark eclipse where moon nearly invisible, to 4 intros, bright copper red or orange eclipse. September 2015 rated about a 3, bright enough to see surface features during totality through telescopes. January 2018 rated similar, clear stratosphere, no major eruptions in prior months. The supermoon component enhances the eclipse visually. Larger apparent diameter means more moon to see turning red. Brighter reflected light before and after. Totality creates sharper contrast with the darkened eclipse moon. Photographers favor eclipse supermoons because the larger disk fills more of the frame. Easier to capture detail, easier to see with naked eye. Total lunar eclipses visible from entire hemisphere facing the moon. Unlike solar eclipses, limited to narrow path of totality, anyone on the night side of Earth during a lunar eclipse can watch the entire event if weather permits. Duration up to nearly 2 hours for totality. Solar eclipses last minutes at any given location. Lunar eclipses provide more viewing time. Combine that with supermoon brightness and size. You get optimal eclipse observation conditions. No special equipment needed, no eye protection required, since you're looking at reflected light, not direct sunlight. Binoculars enhance the view. Telescopes reveal crater details in the partial phases and even during totality with sufficient aperture. But naked eye suffices. The red moon hangs in the sky. Ancient cultures feared it, saw it as omen. Norse mythology told of wolves chasing the sun and moon. Eclipse meant a wolf caught one. Other cultures interpreted it as gods warring or celestial dragons consuming the moon. We understand the geometry now. Still worth watching, still spectacular. The mechanics are predictable. Moon's orbit inclined 5.1 degrees to Earth's orbit around Sun. Eclipses only happen when Moon crosses the ecliptic plane, the intersection line, at new or full moon. That intersection point is called a node, ascending node, Moon moving from below ecliptic to above. Descending node, opposite direction. The node's precess rotates slowly, completing a full circle every 18.6 years. This precession, combined with synodic and anomalistic month cycles, creates the Saros pattern, allows eclipse prediction millennia in advance. Fred Espenac published tables covering eclipses from minus 1999 BCE to plus 3000 CE. Over 5,000 years, every eclipse cataloged with geometry, timing, duration, magnitude. His tables show which eclipses occur during supermoons, which during micromoons. The data enables planning. If you want to photograph an eclipse supermoon, you consult the tables. Find the next occurrence. Note the location, timing, weather probabilities. Make travel plans years in advance if necessary. The 2033 October eclipse supermoon will be worth the effort. Totality visible from prime locations, moon at proxy-G distance, clear autumn skies probable in southwestern United States. Set up cameras in Arizona or New Mexico. Capture the blood moon at extreme proximity. One chance per Saros cycle. One Saros cycle per human lifespan if you're lucky. Here's what most miss. The orbital precession means supermoon perigee distances vary over centuries. They don't stay constant. Gravitational perturbations from planets, especially Jupiter and Venus, tug on Moon's orbit. The eccentricity oscillates. Perigee distance ranges from approximately 356,370 kilometers at minimum to 357,700 kilometers at less extreme supermoons, 400-kilometer range. Over the centuries, that range shifts. In the 20th century, the closest supermoon was January 4th, 1912, 356,461 kilometers. Earth was also at perihelion that day, closest to the Sun in its orbit, triple convergence. Full moon, lunar perigee, Earth at perihelion, produce the closest possible supermoon given orbital mechanics. Won't repeat with identical geometry for hundreds of years. The January 1948 supermoon came close, 356,461 kilometers, essentially tied. The November 2016 supermoon, 356,509 kilometers, slightly farther but still extraordinary. The December 2052 supermoon, 356,429 kilometers, will be second closest of the century. November 2034, 356,448 kilometers, third closest. But after 2098, no more sub 356,500 kilometer supermoons until the 22nd century. The orbital dynamics shift. Perigee distances drift slightly farther, not by much, tens of kilometers over decades, but enough that the closest supermoons of the 21st century cluster in its first half and middle decades. By 2080, the closest supermoon distances will be 356,600 kilometers or greater. Still supermoons, still impressive. But not record setters. The records belong to the early decades, the ones we're living through now. If you're reading this in 2025, you live in the optimal window for supermoon observation. The November 2016 event already passed, but the November 2025, December 2025, November 2034, and December 2052 supermoons remain ahead, all within 356,500 kilometers, all among the closest of the century. Photograph them, document them. because the next comparable sequence won't begin until late 21st century Barker, and the geometry won't quite match. The people who see the December 2052 supermoon, closest of the century, will be born in the 2030s or 40s. They'll be children now, or not yet born. By the time that moon rises, the world will be different. Technology, politics, culture, all transformed. But the moon will still be there, still following the same elliptical path, still reaching perigee on schedule, still obeying Kepler's laws formulated in the early 1600s, still demonstrating Newton's law of gravitation published in 1687. Same physics, same geometry, same celestial mechanics. The Saros cycle that predicted the 2015 eclipse supermoon will predict the next dozen. The 14-month recurrence cycle that brought the November 2016 supermoon will bring the December 2017, January 2019, February 2020, and onward. The terminology might change. Supermoon might fall out of favor, might get replaced by some new catchy term, or astronomers might standardize on perigee, syzygy. Doesn't matter. The event stays the same. Moon approaches Earth. Earth orbits Sun. Alignments occur. Light reflects. We look up. That's what makes these 7 types significant. They represent different aspects of the same orbital dance. The extreme proximity supermoon shows minimum distance. The super blue blood moon shows convergence of 3 rare events. The harvest supermoon connects astronomy to agriculture and culture. The micromoon demonstrates the opposite extreme, proving the variation is real. The proxy phenomenon highlights precise timing. The named moon supermoons overlay cultural tradition on scientific fact. The eclipse supermoons add shadow and color to proximity. Each type tells part of the story. Together, they map the complete picture of how the moon moves through space relative to Earth. 384,400 kilometers average distance, varying by 50,000 kilometers each month. Perigee at 356,000. Apogee at 406,000. Full moon occurring anywhere in that range. Sometimes at perigee, sometimes at apogee, sometimes in between. When full moon and perigee coincide within hours, you get the supermoon. When they coincide within days, you get a less extreme supermoon. When they oppose, full moon at apogee, you get micromoon. The moon doesn't care about these labels, doesn't know it's performing, just follows its orbit, shaped by gravity, perturbed by planets, locked in tidal synchronization with Earth. One face always toward us, the same craters visible every night. Mare Imbrium, Tycho with its bright rays, Copernicus, Aristarchus, Oceanus Procellarum, all mapped, all named, all unchanging across human history. But the distance changes. And that creates the variety. The November 2016 supermoon at 356,509 kilometers looks different than the April 2017 micromoon at 406,662 kilometers. Not obviously different if you just glance up, but measurably different, photographically different. 14% diameter variation, 30% brightness variation. If you put images side by side, scaled properly, you see it instantly. The supermoon dominates. The micromoon looks small. The human brain can't retain that level of visual detail across months. Memory compresses, normalizes. Every full moon looks about the same in recollection. Only direct comparison reveals the truth. That's why documentation matters. That's why photography matters. That's why tables of perigee distances matter. Fred Espinak's tables at astropixels.com list every perigee from 2001 to 2100, every full moon date, every distance in kilometers, every calculation verified against astronomical algorithms by Jean Mias, published 1999, IRS, the standard reference for orbital mechanics. Computations, Espinak assumes full responsibility for accuracy, makes the data freely available, allows reproduction with attribution. That's real science, open data, reproducible results, no gatekeeping. Compare that to how the term supermoon originated. Astrologer creating catchy term for marketing horoscopes. No peer review, no precision, just vibes. Yet the term succeeded where perigee syzygy failed, because humans respond to story. Supermoon sounds dramatic. Perigee syzygy sounds like homework. Even NASA uses supermoon in public communications. Technically correct term in parentheses. Popular term in headlines. That's pragmatism. That's meeting people where they are. The science stays the same either way. Orbital mechanics don't care what we call them. Newton's law of universal gravitation works whether we name the moon super or not. But names affect attention. Attention affects observation. Observation affects understanding. More people looked up at the November 2016 supermoon than would have looked up at a perigee syzygy event. More people photographed it, more data collected, more memories created. That matters. So these 7 types, These 7 ways the moon swings close or combines phenomena, they're not just astronomical curiosities. They're access points, entry doors into observing the solar system. You don't need a telescope, don't need a degree, just need to know when to look up. October 17th, 2024, November 5th, 2025, December 4th, 2025, November 25th, 2034, January 31st, 2037, October 8th, 2033, December 6th, 2052. Mark those dates. Some you'll see, some your children will see, some your grandchildren if you have them. Each one follows from the same mathematics that predicted every supermoon for the last 1,000 years. Each one proves the universe runs on rules we can understand. Not magic, not divine intervention, just gravity and geometry. That November 2052 moon, closest of the century, will occur 2 days after perigee. December 6th, 2052, the moon reaches full phase at 0718 Universal Time. Perigee occurred December 6th at 0852 Universal Time, 1 hour 34 minutes later, nearly simultaneous. Distance, 356,429 kilometers. The moon will sub-10 33.53 arc minutes. Relative brightness, 1.301 times a moon at apogee, 1.163 times an average moon. If skies are clear, if you're alive, if you remember to look up, you'll see the largest full moon anyone will see for the rest of the 21st century. That's 27 more years from now. 2052, what will the world look like? What will you look like? Will you remember reading this? Will you remember the geometry explained here? Probably not, but the moon will remember its orbit, will arrive on schedule, will hang in the sky, exactly as calculated, exactly as predicted, following laws discovered 400 years ago and refined ever since. That's the power of understanding celestial mechanics. Prediction, confidence, knowledge that some things don't change even when everything else does. The next extreme supermoon after December 2052, December 17th, 2070. Distance, 356,466 kilometers. Then December 28th, 2088. Then January 17th, 2098. Last sub 356,500 supermoon of the century. After that, the distances drift slightly farther. 21st century's closest events cluster in first 80 years. We live in that cluster now. This is the era. This is the window. Every naked eye supermoon you see now is among the closest of the century. Every one you photograph is documentation for people who will look back in 2095 and wonder what it looked like. The December 2052 event will be studied, photographed, analyzed, compared to historical records. Your November 2016 images, if you took them, will be part of that historical record. Your November 2025 images will be part of it. You're documenting astronomical history in real time. Every clear night, every phone camera pointed up, every telescope aimed at the moon. Contributing data, distributed observation, crowdsourced science. Professional astronomers use supermoons differently. The Lunar Reconnaissance Orbiter, in orbit since 2009, maps lunar surface temperatures, composition, topography. During supermoons tests, ground-based observations increase. More amateur astronomers looking up, more questions asked, more public interest. NASA leverages that interest to communicate lunar science, explains why we study the moon, explains what we learn. The moon holds clues to Earth's history. Impact craters on the moon represent impacts Earth also suffered, but which erosion and plate tectonics erased from our surface. Lunar regolith preserves solar wind particles from billions of years ago, recording sun's evolution. Lunar geology reveals how terrestrial planets form and differentiate. Studying the moon teaches us about Earth, and you don't need spacecraft to study the moon, just need to look, measure, compare, document. The supermoon gives extra incentive to do that. Makes the moon slightly easier to observe, slightly brighter, slightly more detail visible, not a huge difference, but enough to matter. The 7 types outlined here represent the full spectrum of supermoon phenomena most people will encounter in a lifetime. The extreme proximity supermoon like November 2016, the super blue blood moon like January 2018, the harvest supermoon with cultural and agricultural significance, the micromoon showing the opposite extreme, the Proxy-G phenomenon with its 10-hour window. The name moon, supermoons connecting astronomy to tradition, the eclipse supermoons adding shadow and red coloration, 7 types, 7 ways. The moon shows us variety within regularity, all predictable, all calculable, all observable. All waiting in the sky on specific nights, determined years or decades in advance. That's the gift of astronomy, knowing what's coming, anticipating the event, being ready when it arrives. No surprises except weather, no unknowns except clouds. The moon will be there. The distance will match predictions. The brightness will follow inverse square law. The diameter will match the calculated arc minutes. Count on it. Bank on it. Set your calendar by it. Lunar calendars predate solar calendars in human history. For good reason. The moon's easier to observe than the sun, changes phase in predictable monthly cycle, new to first quarter to full to third quarter to new. 29.5 days every month. Thousands of years. Civilizations rose and fell by that rhythm. We still use it. Islamic calendar is purely lunar. Jewish calendar combines lunar months with solar year corrections. Chinese calendar uses lunar months. Many cultures track time by moons, not months. The supermoon fits into that tradition. Special moon, notable moon, moon worth remembering. And when you remember it, when you photograph it, when you watch it rise on one of those 7 special nights, you're participating in something older than cities, older than writing, looking at the moon, watching it move, noticing when it's different. Humans have done this since humans existed. Cave paintings, 40,000 years old, show the moon. Lunar calendars carved in bone 30,000 years ago. Stonehenge aligned to moon and sun 4,500 years ago. The moon matters to us, always has. The supermoon is just the latest chapter, the latest label, the latest way we mark the moon's importance. The orbital mechanics behind it, those are new. 400 years of scientific understanding. But the observation, ancient. You stand in a line stretching back through every human generation, all watching the same moon, closer some nights, farther others, bright, dim, waxing, waning, always there, always moving, always returning. These 7 types are your guide to the best viewing opportunities in the decades ahead. Now you know what to look for. Know when it happens, know why it happens, know where to find the exact distances and dates, check ESPNX tables, check Earth Skies articles updated regularly. Check timeanddate.com's moon phase calculators. Cross-reference, verify, don't trust single sources. Astronomy data is public, algorithms are published. Anyone can calculate perigee, anyone can check. That's how science works. Transparency, replication, verification. The supermoons listed here will occur as stated. The distances are calculated from established orbital parameters. The dates are confirmed by multiple sources. The physics is sound, and when those nights arrive, when the moon swings close, when it blazes brighter than usual, you'll understand why. You'll know the geometry. You'll recognize the event for what it is. Not magic, not omen, not supernatural sign, just the moon doing what the moon does, following its elliptical path, reaching perigee, coinciding with full phase, making the sky slightly brighter, making the night slightly less dark, exactly as mathematics predicts, exactly as gravity requires, exactly as it always has and always will, as long as the moon orbits Earth and we're here to see it. That's the real story of the supermoon. Not hype, not exaggeration, not media spectacle. Just orbital mechanics made visible, proximity made photogenic, cosmic clockwork turned into public event, 7 ways to see it, 7 types to recognize, all based on one fundamental truth. The moon's orbit is an ellipse, not a circle. And sometimes we pass through the narrow end of that ellipse, and when we do, the moon looks bigger and brighter, and that's worth noticing, worth photographing, worth remembering. Because 50 years from now, you'll forget most nights. But you might remember the night you watched the supermoon rise. Might remember how bright it was. Might remember who you were with. Might pull up the old photographs and compare them to the supermoons your grandchildren see. Might trace the pattern. Might recognize the cycle. Might understand, finally, that we're all just watching the same ancient dance played out in different acts. Same choreography, same music of the spheres, forever and forever, as long as there are eyes to watch and minds to understand. That's what makes these 7 types of supermoon mind-blowing. Not just the size, not just the brightness, but the revelation that it's all predictable, all knowable, all within reach of human understanding. We figured out the universe's rules. We can predict the future. And when the future arrives, when December 6th, 2052 comes around, when that moon hangs huge and bright in the sky exactly as calculated decades earlier, that's when you understand. We're not just watching the cosmos, we're reading it, understanding it, participating in it. One supermoon at a time.